So next up, we've got Lee CALCOTE, who's written for a number of things, including the new stack and, well, what else is on your badge now? Network World and everything else like that. And so he's actually going to be talking about surveying the landscape of container orchestration systems and kind of containers in general. Without further ado, Lee CALCOTE, and you got it.
All right. Thank you, Jesse. Good deal. Good to be in front of you guys today. And moreover, good to be following up Ross. He took it home. He said the things that I think I might just be too scared to say. So thank you, Ross. We're going to talk about characterizing and contrasting container orchestrators today. Notice I didn't use the word comparing. That's not necessarily the intention, and so we're going to get into why we're not necessarily comparing. A little bit about me. My name is Lee CALCOTE, doing some writing and some research for the new stack, for the Network World. I have been here in Austin about 8 years, have been at Cisco and most recently at Seagate. Just pushed off from Seagate this last fall, so if you're hiring, I'm looking. This is how you can catch up with me. So since I've been here in Texas for a while, I've picked up a little bit of an accent. Moreover, as I go to dig into any given topic, I end up, wanting to define that topic. And so in this case, we might come and define, what is a container orchestrator. And when you do that, I like to think that there's a little bit of an analogy that can be drawn here between an admiral of a fleet of ships. I think it's a great analogy to make to what a container orchestrator is. A container orchestrator commandeers a fleet of ships, just like an admiral does. In the container orchestrator's case, it's a cluster of hosts. The admiral is responsible for packing containers onto the ships, making sure they're efficiently stacked, making sure the formation of that fleet is just as so. And so is the container orchestrator, responsible for scheduling containers and packing them into container ships and making sure that they're formed in the right way. So we're going to see what time allows today. I'm hoping that we're going to get through taking a look at characterizing Swarm, Kubernetes, Mesos, and Marathon. My hope was that we would make it to Nomad. I don't think that'll happen. If you've seen the link on the first slide, stay tuned to the slide. It'll be updated over time. We'll get in those other container orchestrators. So a little bit about the comparison that I was talking about. I'm going to avoid political landmines for the most part, to the extent that I can. Also, just recognize that just as you're working on any problem, you reach into a toolbox that's full of tools. And you need different tools for different use cases. You need different tools for different organizations. Different organizations have a different amount of engineers with different skill sets, different levels of maturity in their process. So one tool, just as one tool doesn't fit all, neither does one container orchestrator. So what we're also going to talk about a little bit towards the end here is the notion that container orchestrators can get a little bit, I hesitate to use the word, sort of inception-y and make things somewhat confusing. Each can potentially run each other and sort of engulf the next, and depending upon whose conference you're at, they might be the platform that's running the other one versus not, and so we don't need to go through all of that confusion, but what I want to do today is take us through a little bit of a structured discussion about what the capabilities of each of these systems are, and take us through looking at the same category across each of these container orchestrators. I think it's important to start with what the genesis and purpose of a given container orchestrator was, what language it's written in, who's supporting it. Is it under a certain governance model? How many committers does it have? Why was it created in the first place? Then we're going to talk about some functionalities that are core really to any container orchestrator. One of those being just host discovery, the ability to take your cluster of hosts, put them together in a cluster and discover them. Also service discovery. Hopefully as you provision applications, you can keep track of services that are brought up. Scheduling is another core capability to each of these container orchestrators, and that's the ability to place, instantiate an instance of a container on a host. And there's a fair bit of intelligence that schedulers bring to bear on that. Next, there's modularity and extensibility. So to what extent are these container orchestrators modular? To what extent can you plug in other schedulers maybe? To what extent can you plug in other network drivers or other distributed data stores? Updates and maintenance. I think we're going to take a look at this category both from a perspective of the host, or rather the container orchestrators themselves and the daemons that they run, and upgrading from one version of that container orchestrator to the next, as well as we're going to take a look at what faculties these container orchestrators have for maintenance of applications. So as you're running applications on top of these container orchestrators, do they help you with ongoing deployments and kind of maintenance of the software that you're in fact running? We'll take a look. Health monitoring is another aspect of container orchestrators. Do they keep track of the nodes that are within the cluster? Do they keep track of the health of the application that you're running itself? Networking and load balancing, you can't get away from it. You need those things. Unfortunately, container orchestrators are, for the most part, built around the notion that, they're entirely built around this notion that you've got n number of hosts, and obviously you're going to need applications that are distributed need to talk to each other across those hosts. Finally, we'll look at high availability and scale, which oftentimes comes kind of last, unfortunately, as any product is created. These container orchestrators, I think, have been considered for their HA and scale and those needs up front. So, since we're at the OpenStack Summit, I think it's appropriate to kind of reflect and maybe make a comparison between the orchestrated elements that you'll find in an IaaS-oriented system or a VM-oriented system versus the elements that are orchestrated within a container system. Really, ultimately, it's the same underlying hardware, compute, network, and storage, but the nomenclature has changed a little bit. In this case, it's hosts, containers, services, volumes, applications. That's certainly not the entirety of the vernacular used there, but those are some of the key elements. Also, I'm going to venture a distinguishment between really what functionality is core to any orchestrator, a container orchestrator, and what functionality should it have. And from my perspective, cluster management and scheduling rise to the very top of hey, if the container orchestrator doesn't have those two things, I don't know that you can call it a container orchestrator. Most of them will have these other things we've got listed here as well, where I think you're going to start to see some distinctions between these orchestrators is in how they view the application, whether or not they're treating the application that they're in fact running as a first-class citizen of the infrastructure. So let's start our discussion with Swarm. Swarm, by the way, I think all of you guys are familiar with Rackspace's Carina, and that's what's currently the container orchestrator running behind Carina. We take a look at, let's go through these categories. Let's look at the genesis and purpose of Swarm. I think it's an apt characterization to say that Swarm is simple, easy to set up. If you're familiar with Docker CLI, and that's kind of how you've come to understand containers, you're going to have a real easy time beginning to use Docker Swarm. It uses the same CLI. It is an imperative system, which means that you need to tell it what you'd like for it to do, and it'll do it for the most part. Swarm is the component within the space of Docker's suite of software that's responsible for scheduling and orchestration. So Swarm's architecture is, to the extent that it's simple and easy to set up, you might expect that it's relative to other container orchestrators, its architecture isn't as complex. That's kind of a natural conclusion. Swarm has a couple of entities, more than a couple, but some are managers and agents. The managers are responsible for scheduling the workload on agents. In small deployments, you can have a manager and agent on the same host. Swarm has been written in Go, much like the rest of the Docker suite. It's lightweight, modular, portable, extensible. This is a perspective of kind of the round bubbles of what comprises a Swarm deployment. You'll notice that a little bit of discoloration here. HA, in terms of Swarm managers, has just come out of experimental and is fully supported in version 1.11. Another quick thing I'll point out here is that we're going to talk about service discovery. Ross said a little bit earlier, but here, don't confuse service discovery with discovery service. Swarm's discovery service is about keeping track of all of the hosts in a node, all of the hosts inside of a cluster, and how those nodes are registered to that cluster, how they identify themselves to a cluster, which is distinct from, that's sort of host discovery, not service discovery. So a quick look at support and momentum for Docker Swarm. Lots of people helping move this project forward. Some great statistics. Moreover, there's just a real purpose around community engagement. As a matter of fact, there's a little over 250 Docker Inc. organized meetups. Quick disclaimer, I co-organized the one here in town, so know that. And Docker Swarm was announced as being production ready back at DockerCon EU, which was a great announcement. So I just got into host and service discovery here a second ago, saying that Docker Swarm has host discovery, and that facilitates the upbringing of nodes within the cluster. Ross had pointed out earlier that, in fact, Docker Swarm doesn't necessarily have service discovery embedded in. I think, I think if you really, I tend not to disagree there. I think that if you, as you dig into it more, there's a new notion of network aliases that allow you to assign similar tags to images that comprise your application. And using those same network aliases, you'll benefit from round-robin DNS. There's a DNS server that's been embedded in Docker 1.10, and so you'll begin to benefit kind of service discovery in that regard. I think there are probably folks in the audience who might pick bones with me about that being true service discovery, and I'll leave it at that. So we'll take a look at scheduling. The scheduler in Swarm is pluggable. There have been a few different projects that have swapped in and out Swarm scheduler. Scheduling is a key component to any of these container orchestrators. Swarm itself breaks down the ability to assign scheduling policy kind of into two categories. One is the notion that you choose a strategy in terms of how you want to either spread or compress your load. Spreading out your load does so across all of it does essentially what you think it does. It's the default strategy that for scheduling. As Swarm goes to provision bring up an instance of a container, it does so in an even fashion. Or you can use binpack, which takes and loads up each individual host to their max capacity and moves on to the next. There's various goodness, kind of pros and cons to each of those. I think in a spread fashion, you're sort of spreading out your risk around hosts themselves failing or other software failing. In binpack, you might put more of your eggs in one basket, but you might also benefit from turning down your unused hosts. And so different strategies for you to use. You're able to, beyond strategies, assign some constraints around either affinity or health. And so we won't get into the specifics here. We're going to go through kind of each of the container orchestrators and how they've got essentially this same notion of scheduling policy. And they're, for the most part, pretty configurable. So modularity and extensibility. I mentioned the scheduler is pluggable. So is Swarm's, or the Docker Engine's network driver. So is the key value store that's used for Swarm deployments. It rotates between those common three that you think of: Zookeeper, etcd, console. The one thing that isn't necessarily modular here is the notion that Swarm runs in combination with the Docker container engine runtime, and only that. In terms of updates and maintenance, so updates to the container orchestrator Swarm itself is something of a manual process at this point. I think the hope here is that the community or the folks at Docker will work on kind of a maintenance mode and maybe the ability to sort of assign that to a host and have active containers get rescheduled and rebalanced off those hosts so that, in fact, you don't have to have downtime for your application. That's not the case today. I think Ross pointed that out earlier. Also, and Ross pointed this out as well, is accurate that there isn't any facilities in Swarm today to help you do, or there are some, just it's not, I think if we get really technical, there's some around labels and other things you can do, but there's just no real first-class kind of structured way to update your applications that Docker itself facilitates. You probably need some third-party software for both of those items. Some other third-party software you might need for Swarm is around health monitoring. Swarm, it monitors the health of the nodes that are in the cluster. Absolutely, it needs to keep track of those, which ones are up. Not only which ones are up, but also what resources have been consumed on those nodes. Swarm doesn't, in fact, have that same health monitoring for for your applications that you've deployed inside of containers. So you'll start to see some distinctions here. There's lots of room for the ecosystem to fill in and around Swarm, and a lot of vendors have. So in terms of networking and load balancing, Swarm works in combination with Docker Engine. Docker Engine, multi-host networking was brought forward fully out of experimental in 1.10. Swarm brings that power to bear. What it doesn't necessarily bring right now is load balancing, or at least I'm told by the folks at Docker that load balancing is new in 1.11. I just have scoured, and I've also asked for documentation on that, and I've come up bare. So question mark on that one. High availability and scale. This has been sort of a hot topic across container orchestrators here over the last month or two. Docker has commissioned tests in this regard. Kubernetes has put out some tests in this regard. I don't know that those are necessarily apples to apples comparisons, but I do know that scale is something that, just like all of this whole space, it moves pretty quick, and so does the ability for these container orchestrators to scale. So there's some specific numbers out there right now. I'm not going to post those or go through those. I will say that in terms of high availability, in this latest release of 1.11, high availability is now out of experimental and supported in a multi-manager way, multi-master way, multi-manager way. There's only one active manager at a time. That's really probably due to the fact that Swarm is a single level scheduler. There's one scheduler that can run at any given time in the cluster. And so other managers need to be in standby, sort of replica mode, and can't be authoritative for where a container gets scheduled. Rescheduling is now available as of 1.11. Rescheduling is, when a container goes down and it wasn't necessarily supposed to. Swarm will reschedule those containers. Swarm right now doesn't support rebalancing, which is, if you've got a cluster of 10 nodes and you go to add an 11th or 12th, it doesn't necessarily rebalance the cluster today. Okay. I do just a quick note. I was out at DockerCon EU, and there was an impressive display of scale that was shown at the conference. And so, mind you, this was a few months ago. But what you're seeing here is 1,000 nodes, EC2 nodes on AWS being spun up and joined to a singular Swarm cluster, which is a pretty impressive feat. Directly after this, there were 50,000 containers scheduled across those 1,000 nodes. So when we talk about scale, it's an impressive thing. All right, a couple of quick pros and cons. We don't have to, go through all of these, but just, my takeaways in terms of, things that are fantastic about Swarm, areas where Swarm is still improving. We covered most of them. I'll say that, I think a lot of times people get started using Docker's software itself, and Swarm is a fantastic place, I think, to start, get going, get up easily. Rackspace with Karina helps facilitate that. And then a lot of times what folks potentially find is that they can go out and use third-party software for some of their applications needs, some of the needs that I called out before. I think that's a point of contrast between the container orchestrator Kubernetes, which has a little more of an application-centric perspective. Kubernetes is, it's an opinionated framework, so by that, there's a lot of functionality built in. Kubernetes is a declarative system, so you define what it is that you'd like to have running, and Kubernetes executes that for you. Kubernetes, like Swarm, is written in Go. It's modular, extensible. It's considered something of a third-generation container orchestrator, primarily created by Google, but also by a number of others in the community. Red Hat's probably the second largest contributor there, but also a number of others. this is a quick look at Kubernetes architecture, a little more complex than what we'd looked at before. You're seeing some of the same concepts, essentially between the master and nodes and sort of some of the software that you'll see there. You're also seeing some new things around load balancing being more of a first-class capability. Also, how it is that, what software is being used to monitor the resource consumption of the cluster itself. And so we're going to talk about what those are. When we talk about support and momentum, Kubernetes as a project is a little over 2 years old. Was announced production ready about 10 months ago. Kubernetes has been donated and kind of is under the governance of the Cloud Native Computing Foundation, the CNCF. Actually, for those of you that may have seen it just earlier this morning, KubeCon as an organization was also, or as a conference, was donated to the Cloud Native Computing Foundation as well. There are about 90 meetups or so, depending upon how you measure around the world. I think I saw a measurement earlier today, more like 130, but there isn't necessarily the same set of overarching organization led for meetups for Kubernetes like there is for Docker. Quick disclaimer also, I organize a meetup in town on microservices and containers, and so we do talk about Kubernetes there, so just a disclaimer. All right, we looked at host and service discovery previously. We'd said that I think Swarm had a discovery service. It does host discovery. Kubernetes does as well. When the agent, the kubelet, is deployed onto a host, it can be configured to, by default, come up and look for and register with the master. Kubernetes does have service discovery out of the box. It really has two primary modes of performing service discovery. One is as environment variables, which is probably something of a poor man's approach. I think that's in part there to just be to be simple and also be a way of kind of integrating with an older style way of networking in Docker with links. Kubernetes also has DNS as its service discovery. DNS is deployed as a cluster add-on in Kubernetes. We'll talk about what cluster add-ons here in a minute. So scheduling, that other core concept to a container orchestrator. By default, scheduling is handled by Kubescheduler in Kubernetes. This scheduler is pluggable. There's a theme here of pluggability, both, I think, for all of the container orchestrators. So not dissimilar from how Swarm works with strategies and filters and kind of scheduling policy, so does Kubernetes define scheduling policy through a JSON file. That file contains references to predicates and priorities. Predicates are, for lack of a better term, maybe algorithms that are used to define node resources and the node's characteristics. So predicates are used to determine of the hosts in your cluster, which ones are best suited for, or which ones do I want to identify as being available to schedule containers into. Once that set has been identified, often it'll be more than one. Then priorities, the priorities end of that policy will be applied to then filter out and identify the singular node that needs to be scheduled to. If in case there's actually a tie between those, one is selected at random, and Swarm does the same thing there in the case of a tie. Modularity and extensibility, again, each of these container orchestrators are very pluggable. The difference here for Kubernetes is that it may run either Docker runtime or Rocket runtime. Also, I talked about cluster add-ons, another concept in Kubernetes, which is to say that sort of out of the box, as you deploy the Kubernetes binaries, you can optionally, included in there are cluster add-ons, which are additional capabilities like the DNS that we mentioned a minute ago, centralized logging that you might need. And so these additional capabilities or these cluster add-ons are considered sort of inherent to the system. They're optional. You can deploy them if you want to. And they are scheduled as a pod, just like any other container is scheduled within Kubernetes. By the way, I should have given a disclaimer earlier in this talk. So this talk is not to explain really the constructs of Kubernetes or these systems, but it's just to characterize them against one another. So So hopefully, as I talk about some of these capabilities, you guys are, use some of this lingo, you guys are familiar. So updates and maintenance. So Kubernetes differs here in that, it does, in terms of upgrading Kubernetes daemons itself, there is right now a simple shell script that goes out and will upgrade those hosts. That's, admittedly somewhat, or I think the community has admitted that, that's sort of a starting point, and they need to get that change, get wrapped some better tooling there. Kubernetes has taken a step towards maintenance mode and sort of putting a node into maintenance mode. You're allowed to mark a node as in maintenance. No additional containers will be scheduled into it, but the existing containers that are on that node will remain until they die. And so still work to be done around maybe exiting the host. Kubernetes does differ here in that it actually does provide facilities for upgrading the applications that you've deployed. So your application that you're running in containers, there's rolling updates and some other facilities for you to perform blue-green deployments or canary deploys. So Kubernetes in this regard treats applications as has more considerations for your application and its ongoing lifecycle. Kubernetes is a similar story on health monitoring. Not only does Kubernetes monitor the health of the nodes themselves, whether they're up, what resources are available, how much resources they have left, but it also does some similar things for applications. So your application that might be running in your container, you're likely going to need to perform some health checks to make sure that, in fact, your application is still healthy. Today, Kubernetes provides 3 facilities for doing that: an HTTP health check, I think a TCP socket check, and even executing a container exec, which is identifying a binary or a script that you'd like to have executed in the container, and then you would define its return code to verify that it was healthy. Kubernetes also brings cluster level logging, I mentioned earlier, as a cluster add-on. So both your applications and the nodes in your cluster generate logs. And if you'd like to take advantage of that cluster add-on, you can, and have those logs centrally pushed, or pushed to a central location. In terms of networking, we start to talk about the pod. A pod is really the atomic unit of scheduling within Kubernetes. I'm not going to explain the concept much more than just try to move on and get to Mesos and Marathon and say that there's flat networking out of the box with Kubernetes. Every pod receives an IP address. This eliminates the need for NAT. It also helps remediate some issues around port conflicts, helps localize those, it makes it a little bit smaller. It also, pods themselves facilitate intra-container communication, as a pod actually has one or more containers inside of it, and those containers that are co-scheduled in the same pod, they can just communicate over localhost. So load balancing is also an out-of-the-box feature. That's provided for by a component called kubeproxy. Kubeproxy is, if you recollect on the architecture slide, is on a capability on each of the hosts in the cluster. It provides, kubeproxy facilitates the notion of a service. And a service is how you might provide a layer of abstraction in front of your containers, and in front of the way that they communicate with the rest of the world. So this really begins to facilitate that load balancing. All right, in terms of high availability and scale, I'd said that we won't quote recent scale tests, but we'll leave those be. We will say that, similar to the active standby story that Swarm had, so does Kubernetes have an active standby configuration. And I'll posit that there can only be one active manager, similar to Swarm, in that this is a level 1 scheduler. There's only one instance of the scheduler in a Kubernetes cluster, and it is authoritative at all times for scheduling activities. Should that master fall over, one of those replicas will need to step up and then be authoritative for scheduling. So really just the issue here around, not necessarily an issue, but just the issue, or the concept here between Swarm and Kubernetes, both the same in the notion that they're single level schedulers. We've got one scheduler active at any given time. We're going to see a difference when we get to Mesos and Marathon. So I guess I lied. I guess I do talk a little bit about some recent tests that were announced as part of the 1.2 release, the latest release of Kubernetes. But maybe even more interestingly is sort of Kubernetes' step towards federated clusters, which is to say that you might have a Kubernetes deployment today that has n number of nodes in your cluster. Well, currently, if you go and deploy another set of masters and another cluster, those two aren't necessarily going to be cognizant of the fact that, in fact, there's multiple managers, multiple instances, and they need to communicate. That's not available. That's sort of under the flag of what Kubernetes would be. Today, what's been brought forward in 1.2 is support for multiple, essentially availability zones under the same manager. So application level auto scaling is supported. So another consideration for applications within Kubernetes, and that auto scaling up and down is facilitated by replication controllers. A quick look at pros and cons. Maybe just a couple things to point out. I'd mentioned before, your choice of container engine runtime is available to you at least between Docker and Rocket in Kubernetes. A lot more built-in functionality that you're seeing here. It's just, it's got an opinion about how things are done. It's built into the framework. If you like it, that's pretty fantastic because you're really going to need that stuff and want it as you go to run your applications in a containerized environment. If it disagrees with you or you in fact don't like it, then it can be a little bit bothersome because you're going to have to open up the hood and either remove some things, swap some things out, or use a different container orchestrator. One of the issues with something like Kubernetes is just it's got a lot more there's just got a lot more things to understand. Of the mouthful that I just kind of went through in those slides, that means that you've got to come to understand pet sets, job sets, daemon sets, pods, replication controllers, lots of good stuff that help facilitate running applications. But it's just compared to other container orchestrators, it's just more to learn. Got some decent documentation out there, by the way. I will give them that. So are we on time? Are we all right? Good. So let's get into Mesos Marathon. So Mesos is the oldest of these. I don't even know that it's necessarily apt to characterize Mesos as a container orchestrator when I just say it in that sentence. What we're talking about right now is Mesos and Marathon. And that is a container orchestration system. Mesos itself got started, sort of predates Docker and kind of the popularization of containers. And so it was built in the time of kind of bare metal, of big data, of doing batch processing, job scheduling. It's really good at those things. Because it's been here longer, it's had more time to bake, more time to grow at scale, more time to build in functionality. It is distinct from the other container orchestrators that we talked about. It is in fact not a mess written in C++. Please no one quote me on that. But it is Mesos is written in C++. It has Java, Python, and C++ APIs. That's a consideration point for those that are getting into the container orchestrator heavily and investing to the extent that you might need to touch some code. It's good to just identify what each of these systems are written in. So Mesos, I'm going to talk about it being distinct around the fact that it does come with the two levels of scheduling, and that's kind of why we're talking about Mesos itself and Marathon as a framework. So Marathon is one of a number of different frameworks that you can provision on top of Mesos. Mesos is really this, I guess I try to articulate it here. It takes a collection of, it's grid computing, so to speak, if I could use that older term, that brings together a resource of hosts, abstracts away their resources. Mesos itself then ends up offering up, keeps track of the resources on the nodes. It makes offers to these frameworks saying that here's availability, resource availability from the hosts. And the frameworks can take advantage of that and say, I've got a job that I need to run or a container that I need to instantiate and schedule. And it may accept that offer and go ahead and execute those tasks. Actually, in this case, containers on hosts. Marathon itself is written in Scala. Here's a look at the architecture. I think there's a variety of the way that you could draw this, but again, not quite as simple as Swarm. So I think that's one of the takeaways that we'll get at the end is that Mesos is one of those that you might need. It's a very, how do I say this correctly? You might need more IT staff to take care of it, I guess it's a very capable, powerful system. I think with any system like that, it's hard to get that dead simple and make it just super easy to run. So it does have a fair bit of support. Like I said, it's been around the longest. I'm not sure, again, kind of the best ways to measure this. Commits aren't necessarily, one commit size might be a line of code, or another one might be, this big, and so, but it's certainly got a good following. It is under the governance of the Apache Foundation. It's been used by some of our world's largest internet companies, and as a matter of fact, used by a company that's got a location here in town, Yodel. Host and service discovery. So this Mesos and Marathon is probably somewhat similar most similar to Kubernetes in this regard, in the notion that it does have service discovery. It facilitates. It does have host discovery. It facilitates the bring up of your cluster. It also does have service discovery. These are service discovery itself is pluggable. Probably the most common project used here is Mesos DNS. So again, using SRV records to let your applications come up, announce themselves, register both their IP and their port. So we talked about, I alluded to this earlier. I said that Mesos is distinct from the other container orchestrators in that it has two levels of scheduling. And I actually already spoke to the fact that the first level happens down at Mesos itself, where it runs allocation policies to say what resources should be allocated to what frameworks. Marathon is one of those frameworks, probably a popular container orchestrator framework. There can be other ones, Kronos, Aurora, a number of others that I'm not as familiar with, that can receive offers and receive requests to use the resources offered up by Mesos. And so anyway, point being, two levels of scheduling, that gets us into a little bit of a different conversation when we get to high availability and the way that multiple masters run. An interesting note here is that part of this scheduling provides for some things you might only find kind of in VM land, maybe specifically VMware land at the moment. Actually, I might step on myself with Nova maybe having this, and I'm just not sure. But is the notion of reservations and the ability to oversubscribe your infrastructure. It's kind of a dangerous place to be in, but modularity and extensibility. Again, very similar story. In this case, Mesos is probably arguably more modular and extensible based on the fact that it's got more components to swap in and swap out, particularly around those frameworks that we were just describing. So it's not uncommon to hear that hey, Mesos can run the other container orchestrators as a framework, and those projects have been proven out and are there. I don't know that I'm not sure what the use case there is. It might be just that you're invested into Mesos already, and you'd like to get into some of these other ones, and so just like running OpenStack on top of VMware, probably the same type of hey, people know VMware, so let's run OpenStack on top. People know Mesos, let's run it on top. There are so modules that you can write and plug in and out. There's three types of modules in Mesos. One is just simply a replacement module, so you just displace the other capability. The other one is more of a hook, probably not necessarily pertinent to container orchestration. Updates and maintenance. So Mesos has been around the longest, has had a longer time to address some of these use cases, and in fact does around host maintenance modes. So Mesos does have a maintenance mode, and it actually does not only facilitate the ability for you to ad hoc identify a host as being undergoing maintenance, it also helps with the exodus of the rescheduling of those containers off of that host. Moreover, it allows you to schedule a maintenance window as well, which is kind of nice. Marathon specifically does provide a lot of faculties around applications and what applications need. And we talked about some of those with Kubernetes. Some of those here are in terms of just blue-green deployments, canary deployments, that type of a thing. So health monitoring. There's kind of a check in the box for Mesos and Marathon here as well. Mesos, the master, does keep a variety of statistics and metrics by way of kind of counters and gauges of the resource consumption of the hosts in the cluster. At an application level, Marathon provides for, again, those health checks that we talked about with Kubernetes, both by way of HTTP health checks and TCP health checks. It also provides an event stream that you can integrate into load balancers, so you can analyze your metrics. Networking and load balancing. In this case, most recently, there's been some change. I'm not sure what the date was, but some change around, instead of having IP addresses on a per node basis or per slave basis. In fact, each container that's scheduled gets assigned an IP address. And this really constrains the problem space in terms of port conflicts. Also, I guess primarily in terms of port conflicts. It also, because of that same model, a container per IP address is the same model used in Swarm and kind of Docker land. That also facilitates then integrating it, plugging in third-party network drivers. So in terms of load balancing, that comes out of the box with Marathon. You got a couple of choices. I think depending upon who you speak with, they might say, you're probably best suited by plugging in something like traffic, but Marathon LB is there as well. Okay, high availability and scale. This is certainly a key strength of Mesos' architecture, kind of from the start. I think I shied away from talking specifics around scale of the other container orchestrators. I think it's fair to state that Mesos is probably the most proven in this regard in terms of its kind of tens of thousands of scale. Mesos does, use Zookeeper to keep a quorum of its masters. While I think Mesos is capable of having multiple masters active at the same time, I don't believe that Marathon is. So recollect, there's two levels of scheduling. That first level, Mesos, can have multiple masters active. Marathon itself, only a singular active leader at a time. So again, we already mentioned some of the companies that use Mesos. It's great at what I mentioned before around asynchronous jobs. At one point, Solomon Hykes had said that Mesos is kind of the golden standard for container orchestration. That was a little while ago. I'm not sure if that's true anymore. A couple of strengths that Mesos and Marathon bring are the notion of something that we talked about with Kubernetes, but it was like the fact that you get your choice around container orchestration engines. But moreover than that, you get your choice around frameworks as well, which is just brings that choice to another level. Mesos and Marathon are really the only ones that I think Marathon's recently overcome some issues in this regard, but that you can say is enforces multi-tenancy. The other two orchestrators don't have constructs for tenancy. Mesos is good for big data workloads and data locality policies, if that's important to you. As a matter of fact, Adrian Otto gave a talk not too long ago on a lot of this stuff. So Adrian's, I think, been a guy to point this out before. Marathon, while Mesos has been around a long time, Marathon itself hasn't necessarily. So it, as a container orchestrator scheduler, is still young as well. I think that's probably an important note to take away from kind of contrasting each of these and characterizing them, is that they're all relatively young projects. I think Kubernetes and the folks that are behind that will be quick to point out that they've got just a long heritage of running containers at scale, and I think have got a fair bit of understanding where they want to go, specifically around applications, and are bringing that to bear. So, good. Okay, so in summary, I've tried to make it clear that different tools for different teams, different tools for different use cases. So I don't think it's an apples to apples. I will, submit this, and I feel that, if someone wants to challenge on this, I feel like I'll probably try to stand my ground and say that I think this is, for the most part, accurate. This is absolutely an extremely high-level perspective of sort of where these things fall in a spectrum of sort of over on the left-hand side, sort of ease of use and just the number of capabilities that they bring. And then just sort of coming over to the other end of the spectrum in terms of just how much they scale, what their level of maturity, their level of modularity. There's a lot of overlap in there, which can make some of this confusing, but my hope is that today's characterization and contrasting has been enlightening of at least some of the pivot points that you might use for a decision in which of these to use. So with that, do your worst with questions, just, if we've got time. So Yes, sir. Everett.
So where does Mesosphere, the company behind Mesos, they have DCOS now? Like, I still haven't quite teased out how to look at what is it? Is it rebranded Mesos? Is it something new, something different?
Yeah. So the question was from Everett Toes. Great question. Just calling out the notion that Mesosphere, the company behind Mesos, has recently launched DCOS 1.0 and is part of their offering. And so what's special about it? What does it bring to bear? How does it? I'm going to take a crack at this and say that I'm I'm not the authority here. I will say that. In my understanding, some of the hiccups that have been seen, that we kind of pointed out around Marathon being young and maybe not having all the things that we necessarily desired, I think when Mesos and Marathon are running on top of DCOS, which my understanding is a data center or operating system, I don't know how much it squares off against something like CoreOS or Atomic. In my mind, those are purpose built for running containers, those two projects, and one of them for being extremely secure. DCOS, I don't know how it compares to those, but in my mind, it's an underlying layer that Mesos and Marathon can run on top of. And when they do, I think there's a better together story there in terms of some of the issues that we saw. Again, disclaimer, I'm not the expert. Good question. I did have, just in all fairness, Michael Hassenblas actually review sort of my research on Mesos, and I had David Aronchick. Maybe I should just give thanks to these folks: Kelsey Hightower, David Aronchick, Tim Hawken, who is hopefully here in the crowd. Thank you for that. Also, the folks at Docker. For the most part, their marketing team was kind enough to weigh in. I think they had some backing from their engineering team, but I tried to just be as accurate and fair as possible. So. Who's
any other? Ooh, I found the sweet spot. It's got a Wi-Fi thing. Any other questions? We've got a limited Wi-Fi range, so I have to stand here.
Perfect.
No other questions from Lee? Then I guess.
Much appreciated. Thank you all.